So it's LeetCode problem for 16 partition equals subset sum. So in this problem we are given an array of positive integer, okay, and our task is to check whether we can divide this number into two separate groups such that both groups have the same total sum. Okay, there are some important rules. Every number must be used only once. You cannot break or modify any number, so you just need to decide whether equal partition is possible or not. So final answer will be either true or false. Okay, now let's understand with example. Suppose we have number like this. Okay, 1 1 5 11 and 5. Okay, so if we try to split them into two groups, so group 1 is, so group 1 can be level and group 2 can be 1 5 and 5. So 1 5 5 is level and this level. Okay, so both groups have total sum equal to level, so in this case partition is possible. The answer is true. Okay, let's take another example. Now consider we have numbers like this: 1 2 3 5. Okay, 1 2 3 5. If we have numbers like this 1 2 3 5, the total sum of all numbers is level. Yes, level. Okay, if we try to divide this into two equal groups, each group must have sum 5.5, but sum must be whole number, so this is impossible. So the answer is false. So in this case, okay, let's consider we have numbers like this: 3 3 3 4 5. Okay, we can split like this. Group 1 will be 4 and 5. Okay, in group 1 4 and 5 is total is 9. In group 2 3 3 and 3, so its total is 9. Both groups have equal sum, so the answer is true. Okay, so basically the problem is asking, can we divide the array into two subsets such that both subsets have exactly the same total sum? That's the main idea of this problem. Okay, so let's try one. So we have numbers of array like this: 1 2 3. Okay, can we split the array into two subset with the equal sum? So as we can, so total sum of this array is 6. So target is, so wait, in group 1 1 2 is 3 and 3, so it's 3. We can split, so the is total divided by 2 is 3. So the question is, can we find a subset of 3? So let's try that. If we start from, we use function solve index comma target. So index is 0 0 1 2, so index is 0 and target is 3. Wait, see, index is 0 and target is 3. Let's try now. If we take 1, it's become 1 comma 2. If we have two parts from this, if we take 2 comma 0, if we skip, it's like 2 2. If we skip 2, okay, if we skip 1 comma 3 and then 2, if we take 2 comma 1 and if we skip 2, it's like 2 comma 3. This you have two options. If we take 3 comma 0, if we skip 3, it's 3 comma 3. Okay, so see, let's see. Step 0, number is 1, so take 1 means new target 2. Okay, if we skip target 3, it's look like 1 and 3. Okay, so in step 1, if we take 1 comma 2, so number is 2. If take 2 is 2 comma 0, target is 0, so it's successful, so the subset is 1 and 2. Okay, if we skip 2 comma 2, is number is 3. If we take 3 comma negative 1, and this was now, and if we skip 3, it's equal to 3 comma 2, and this was step 1b. We have 1 and 3, number is 2. Number is 2. Yes, number is 2. Target 3, take 2 or skip 2. Okay, if we take 2 comma 1, so number is 3. If we take 3, it's 3 comma negative 2, it was wrong. If we skip 3, it will be 3 comma 1. If we skip 2, so 2 comma 3, so number is 3. If we take 3 comma 0, so subset is 3. Okay, because target becomes 0. If we skip 3, it's 3 comma 3, so it's so every step we choose, take or skip, base case is if target is equal to 0, it's success. So index is greater than or equal to n, or target is less than or 0 to is fair. If any part returns true, then return true. So recursion explore all possible. So here we explore all possible. So let's write down the code in recursion. First we write a function so I int target vector int and nums. Base case if target is equal to 0, return true. If target is equal to 0, return true. If I is equal to nums dot size or target is less than 0, return false. Okay, now return solve I plus 1 target minus nums of I, nums or solve of I plus 1 target comma nums. If we skip now, sum is equal to 0 for int x is to nums. So sum plus is equal to x if sum is modulo by 2 is not equal to 0, then return false. This is odd case. In odd case, if return sum divided by 2 and nums. So it's run. We use solve of I and target means we are at index I, we still need target sum. Okay, at every number we had to choose take or skip. Okay, so in recursion tree some states repeat again and again, like 2, 0 yes. See, in recursion tree some states repeats again and again. If it's row 2, 3, 2, 2 and 3, 1, many branches reach the same index target. Okay, so the time complexity of this is big of e2 theta n. So for this we are going to use memoization memo. So the idea is in memoization work. In memo, if I already solve I and target once, so we solve again. Okay, we just stole the answer, we not solve again. That's it. So we stole the answer. Memo of I and target is equal to reset. If we solve once, we store the answer in memo. Okay, next time we same state comes, do not run. No, we don't. Recursion just return store answer. Okay, if we have nums like this, if we have nums of array like this 1, 2, 3 and total sum is 6, so the target is, this is total, the target is 3, so we solve 0, 3. Memo map, in memo map it's like this. We're going to use map. Okay, so first key is equal to say 0 and 3. Okay, now memo check not present compared, so take, if we take 1, solve of 1, 2, if we skip 1, solve of 1, 3. Okay, next step, if key is 1, 2. Okay, not present, so compared we choose take. If we take 2, so solve of 2, 0. If we skip 2, so solve of 2, 2. Okay, so next is solve of 2, 0. If no target is equal to 0, so it's success. So here we are going to return true. So solve of 2, so solve of 2, 2, key is 2 by 2, not in memo, so we compare, we choose. If we take if we take 3, so solve of 3 is negative 1 out of 1. So if we skip 3, the solve of 3 comma 2, so memo of 2 comma 2 is false. Okay, so here we are going to return false. Okay, so we back to 1 comma 1. So we back to solve of 1 comma 2. So here the result of this is true or false. So the answer is true. Okay, in we store in memo 1 comma 2 is true. Okay, if we come to we solve step 3 solve of 1 comma 3. So okay, not in memo, so we compare, we choose if we take 2, so solve of 2 comma 1. If we skip 2, it's solve of 2 comma 3. Okay, so we come back to solve of 2 comma 1. In key it's we store like this 2 and 1. So we compare. So if we take 3, solve of 3 by negative out of 1, and if we skip 3, it's solve of 3 comma 1. So in memo 2 1 will store false. Okay, so next is, so key is equal to 2 comma 3. So solve of 2 comma 3, not in dp, we compare. So we take, if we take 3, so solve of 3 comma 0, so it's true. So if we skip 3, so solve of 3 comma 3 is false. We store in dp, no, we store in memo like this, memo of 2 comma 3 is true. Okay, we back to solve 1 comma 3. So the result is true because memo of 1 comma 3 is true. 1 comma 3 is we have solved, so it was true. So we back to solve of 0 comma 3. So the result is true because we stole this 0 comma 3, so it was true. So see, let's write down the table. So see, memo of 2 is false. First we write memo of 1 comma 2, next is memo of 2 comma 1, and next is memo of 2 comma 3, next is memo of 1 comma 3, and next is memo of 0 comma 3. So it was true, it was false, and it was true. This was also true, and this was also true. Okay, so memo store index remaining target. Okay, remaining target. So not numbers, not subset, only state result. So let's write down the code in memo. So first we create map. Unordered map string and memo. Okay, next we return false, and we use to convert if no string key is equal to string of I plus to string of target. Next we just do if memo dot count key dot key return memo of key. Okay, next we just return memo of key is equal to swap of I and not swap I. Yes. So that's all.